Oftentimes in production lines, we are limited by the space available for our computer vision systems. This can of course be a challenge in itself, but even more so if we are looking for small defects on very big objects. To solve this issue or problem, we sometimes go to line scan cameras. As you can see, the camera is hanging straight above the conveyor, which means that the camera system itself does not require a lot of space in the production line. Imagine that we have a very big object going through our production line. It could be a kitchen front. Here we just scan one line at a time. Instead of, let's say, you scan in a normal image, you would scan something that would be 3,000 lines by 4,000 lines. And also, this makes the system very fast because we can scan up to 4,800 lines per second. So this means that we can have a pretty high resolution even when we have a conveyor moving very fast. After having taken all those lines required for the image, the software stitches those lines together into one big image. We now need to find the defects. To do that, we often use a combination of using normal computer vision and some machine learning to actually classify the defects themselves. The tricky part of using a line scan is actually the installation of it itself, because you need to be very accurate both with how it's angled regarding the conveyor, but also regarding speed, so you know that you get the right amount of lines for the object you want to inspect. This is of course very dependent on which product we're trying to scan and what kind of defects we are looking for. If we are looking for very small defects, it will require us to have a very high frequency. Whereas, let's say we are looking for very big defects, well, so the speed isn't that important and we can have a lower frequency. An additional challenge of this process could be that the object we're actually looking at has different thickness. And when we have different thickness, well, the way the light is reflected often changes. To counteract this, we normally use an actuator, which allows the camera to move to fit the angle of the object we're looking at, and thereby always fitting the right system to the right defect. This process will be done automatically. We will predefine some thicknesses and predefine some positions for the camera to fit those thicknesses. Another challenge we also have is, let's say we have a different type of product. We have something that's white and we have something that's black. It's clear that these two objects will require different lighting. This is also something we can adjust in our products by changing it from within the system. So let's say we have a dark object, we will then turn up the volume or the brightness of the light to actually see the defects that we want to see. Whereas on a white product, if we had the same brightness, we would not be able to see anything. Therefore, for a white surface or a product, we will have to turn down the brightness to actually see the details we need to see. This way, we are able to solve a seemingly very hard problem by taking a very big image, even though we have very limited space available for our computer vision system.